Welcome back to Algebra 2. Let's go and get started today with our warm-up. Today we have two problems out of the book, bubbles and science. First one, bubbles. The volume of a soap bubble can be estimated by the formula V. What do you think that stands for? Anybody got a guess? V? Capital V? Volume, yeah, the volume of the bubble equals 4 pi r squared, where r is the radius. The graph shows the function of the bubble's volume. Describe the end behavior of the graph. Okay, end behavior, stuff, right? So there's two. If you look at the graph, it doesn't even exist on the left, right? So I can't really discuss what the end behavior would be on the left because it doesn't exist. Nonetheless, it does exist on the right. So usually as x goes to infinity, we say that the function goes to, well, what's it doing? As we go to the right, the function's going what? Positive infinity, exactly. So in classical terms, I would write straight up math, I'd say, okay, two ways. You could say the function goes to infinity, the height goes to infinity, as x goes to infinity. This means, again, going to the right, correct? I'm saying as I go to the right, this thing goes up. On the test, I probably won't write it like that. I'll probably write version, but I put a limit in there. But you recognize the same thing. X goes to infinity, right? Still means goes to the right. So I'm still looking for what the answer is. What's this thing do as I go to the right? And it goes up to infinity. And that's a fine, straight up math answer. Now, this particular graph here, though, it doesn't involve x's and y's. It involves volumes and r's, right? Let's try to redo this a little more maturely. Maybe I could say, instead of x going to infinity, what's really going to infinity? It's not the x-axis. What's this axis? It's the, what's that axis? What, r, yeah. As r goes to infinity, same. This thing, now it's not just some functions, as a function gradient goes. That's the answer. When the time comes on the test, I won't, oh gosh, what do I do with this V's and R's, stuff like that? It won't be anything strange like that. But again, here's your straight up algebra interpretation. Going to the right, it goes, as it goes to the right, it goes up. As it goes to the right, it goes up. And if you want to fancy up in the actual terminology of what they're talking about, that's the second one down there. Okay, let's move on. Second one today is about science. The table shows density, pressure, temperatures, and interpret the end function as temperature decreases. Now, I hate tables. Tables are so hard to decode. So the very first thing I do when I have a table is I go kind of plot it. So here's kind of what the table's saying in full format right here. It's density. And I just kind of roughly sketch those points on there. That's not an exact science right here. Nonetheless, it'll work just fine. So here's my graph. Here's my rough points for density versus temperature. And we're good on this. What do you think happens to this thing? It's all about end behavior. What do you think happens to this graph as you go on forever? Take a guess. What do you think is going to happen? Take a guess. Maybe negative infinity. Problem. I would say, oh, this graph looks like it's just going down steady. That's cool. What's this a graph of? This is a graph of density, right? Remember what density is from chemistry or anything like that? Kind of? Okay, that's probably not long enough. But density is basically how much stuff you got per volume. Oh, it's how dense it is, Can you have a negative density? Can you have a negative in a volume? Can you have that? It doesn't make any sense, does it? So mathematically, I agree. It looks like it goes down forever. But I would say realistically, you can't have a negative density. So the what I'm going to do is maybe level right here. Value is it's approaching the density of 0. Right? So that's what I want. Right? The end limit as, I'm not going to say x. I could, but this is temperature, correct? So I'm going to say as temperature, capital T, goes to infinity, as this graph goes right, this thing I'm studying which is density. That technically it's this little row thing. Here you can just write here, you can write the flexible, you can write whatever you want. The density is 0 right there. That's what's going to approach as we go far out. I look at infinity, but with real world applications, you always have things like that because there's real constraints in domain and range and codomain and things like that. The codomain numbers couldn't get out negatives, could you? So your codomain, it was possible to get out above there. All right, LGs now, let's write those down. We'll talk about hopefully. There's one other little skill in this unit that the book didn't cover in depth, and I'd like to do that real quick. How do you write where things are increasing and decreasing? It's very easy. I don't know why people struggle with this. I don't think you guys will. You're smart. You're smart. I don't think you guys will struggle. I don't know. I don't understand throughout the years why this is such a struggle, but you can look at it. These guys are pretty good at reading graphs. I'll give credit where credit's due. Of course, notes after this. And let's go ahead and get started on that. So your homework over section 1.3 is due today by 3 o'clock. Make sure you get that taken care of. You have a new one, of course, over this stuff. 2-day turnaround always. You have a weekend also. That's great. So you have all the way until Tuesday to get the newest one done about sketching curves. But it's online, so most of them will probably just give you descriptions and possible graphs, and maybe you have to figure out which one is the correct one. All right, we're doing section 1.4 today. The title is Sketching Graphs and Comparing Functions. It's found on page 31 of your online textbook. Sketching graphs. Sketching some graphs. First thing I want to talk about, it's not formally in your book, but it'll be on your test, so let's talk about it, is something about just increasing and decreasing. And it's such common sense what I'm talking about. If I'm saying where's something increasing, I mean where is it going up? You know, when's a graph going up, essentially? And if I'm asking when something's decreasing, I'm asking where it's going down. That's it. The whole thing about these two terms is I want to know the x values on the x-axis where this is occurring. So on a test, it might say, oh, tell me the interval where it's increasing, tell me the interval where it's decreasing, et cetera, et cetera, et cetera. And your job would be to just read the graph and see what x values it's going up and what x values it's going down. That's it. We're starting to get to problems that involve a calculator sometimes, so if you haven't got that yet, make sure you get that. And very soon I will record some tutorials on how to use your calculator and post them online. How to graph them, how to change your window, how to zoom. No. No higher goal than being a YouTube star. No higher goal than being a YouTube star. I'll just do a quick example of this. I won't beat a dead horse today. I'll keep pounding this into you as we go along throughout the course, but one example will suffice. So if you look on the board right now, you have a graph, and it's got some extrema. What do I mean by extrema? Maxes and mins, very good, okay. Now let's just say you knew where they were. And again, if you walk in from the left, I want you to tell me if you walk in from the left, always coming from the left, what's going off the graph? Is it going up or going down? It's going up, it's increasing. Okay, so what X value am I coming in from? Negative infinity, right? And until what X value is it going up? Until -2. So here's how I would first write that. First plots, one that says I and D, they stand for increasing and decreasing, or I might actually write the word decreasing and not confuse it with domain and things like that. But you just told me from negative infinity until -2, this thing is increasing. So again, we're going to use that parentheses and brackets kind of stuff all year long. So you're negative infinity to -2, increasing. As soon as you get to -2, though, this thing starts to go down, correct? Until what X value? Until -1. So for decreasing, I'm going to write -2 to -1. It's going down between them. But we're not done. You got to keep going. You got to go the whole way through the whole domain. From -1 until 1, I would think that the graph is going up. So it's increasing again, right? So remember, when you have different pieces, you put a little U between them. That kind of glues them together. And you're saying from 1 until 1, it is going. Then, from 1 to 3, this graph looks like it's going down. So it's decreasing again. Back it onto the decreasing. Union, 1, 2, 3. And you just keep doing this the whole way through until you're done, or pretty much now, because from 3 on to infinity, this is going up and increasing. So I throw one more on here, another U, 3 to infinity. And that's all there's going to ever be to increasing and decreasing in my class. You can look at a graph and see where it goes up and where it goes down and glue them all together like that and just go logically left to right. Then you're going to be fine. That's it for increasing, decreasing. I will keep hitting that skill, though, as we proceed. All right. Now, the book wants you to consider where it's increasing, decreasing. They'll start using that terminology. They won't ask you to write down that kind of stuff, but I will. This is the kind of stuff they're going to ask you to write down. Most of this stuff is things we've already covered. Let's just review real quick. Don't even look. Don't look at the definitions. Okay. Let's review everything from the unit. Domain. What's domain? All the x's. Cool. All right. What's the range? All the y's you get out. Correct? Sweet. What are the intercepts? What does it mean to have an x-intercept? That's where you cross the x-axis. Y-intercept where you cross the y-axis, obviously. Symmetries we've been talking about. Anybody remember what even is? An even function? That's the one where if you flip it across the y-axis, the same on both sides. Or it could be odd. That's one of those things where if you flip it across the origin, it's the same on both sides. So those symmetries are always good to consider. Extrema, we just got to talk about those. Those are maxes and mins, correct? And, whether it's going up or down, increasing, decreasing, the thing I just mentioned. And that's basically it. If you have those kind of information, there's positive and negative too. We don't have to worry about that. You can probably make a rough sketch of a graph. So let's practice making a rough sketch of a graph. All right, this is example 1. I would just write down example 1 because it's right out of your textbook. I wouldn't bother writing down all the setups and all this stuff. The first one, they give you the answer, but most of your problems are going to be a blank graph. You're going to have this information given to you right here, and this will be completely blank, and your job is to figure out what that graph should look like based on the stuff. Well, let's see what we can do here. Example 1, example 1. All right. Here we go. I'm going to pretend that graph is there. And I'm just going to start, making notes of everything they tell me here. They tell me the y-intercept is at 0, -70. So that tells me it crosses the y-axis, right? Where x is 0 and y is -70. I don't know where that is. That's like down here, right? So this is a point on my graph. All right, this must exist. Y-intercept at 0, -70. Sweet. Dang it, it's not going to do this all day again, is it? Stupid camera. Mm-hmm. It is weird. Linearity. What's linear mean? Just a line, right? And it says it's linear. It says it's linear. So whatever I graph, somehow, some way, it's going to be some kind of line going through this point. Okay, I know that. Check. Positive. It's positive. What do you mean by positive? When a graph is positive, that means it's above the x-axis. Positive numbers are up here, correct? If it was negative, that means it's below there. So they're saying it's positive for x's where the x is less than negative 30. So where's x negative 30? I don't know. Here's the x's, right? Let's say this is negative 30 right here, and it's positive for x's less than this. So over here, it must be positive up here. And if it's positive for less than negative 30, I bet you at negative 30, it's exactly equal to 0. That probably is a good bet. Does that logic hold up? If it's positive up here, and it's got to go through here, and from negative 30 on. So I think we got 2 points. Can we just draw a line through it because it's a linear thing? Yes, we can. So you draw a little rough sketch of the line. And does that fit all the bills? Let's see. The y-intercept, is it 0, negative 70? Yes. Is it linear? Is it a line? Yes. Is it positive for x's that are less than negative 30? Yes, it's above the axis there. Okay, we didn't read the rest. Decreasing for all values of x. As I come in from a negative infinity, is this thing always decreasing? Yeah, okay, it all works out. And end behavior, let's check the end behavior here. What does this mean right here? As x goes to infinity, that means going to the right. It's telling me that the function goes to negative infinity, goes down. So as I go to the right, I go down. Yes, okay. And the other one says as x goes to negative infinity, which means to the left, the function goes up to positive infinity, and that everything matches, right? Okay, I'm 1000% sure I'm right. I got the answer right there too, so I know I'm right. But in the future, they won't just give you answers; they'll just give you random problems. And no idea what this looks like, but we will figure it out. This is no new terms or me talking. Just going to be a few examples where we graph things. Use the function sketches. All right. First off, it's the y-intercept is at 0, p. So 0 over in the x's and 3 up in the y's. There, we got a point on our graph. Cool. 30, it's not linear, so that means it's not a line, right? There's going to be some curves or something. I don't know what yet, but we'll figure out from the rest. Continuity. Ooh, that's an old one. Anybody remember what that word means? Continuous? That means I can draw it without picking up my pencil. Remember that one? Lots of in front of you this season already. So whatever I draw, it's going to be curvy because it's not linear. And I'm going to be able to draw it in one big stroke because it's continuous. Okay, good. All right, let's see. Positive is positive for all values of x. So for any x value, it's going to be above the axis. We're never going to go down here. Okay, mental note. I'm going to just make a note of that to myself. I'm going to cross that. You don't have to do that, but I'm going to make a note to myself. I'm going to cross that out. We're never going down there. All right. Decreasing for all values of x such that x is less than 0. That's important. Okay. So first off, such that x is less than 0. Where's x less than 0? Over here, correct? So you're talking about on the left side. They're saying it's positive for all those values, so it's always above the axis right here. So it's going to be up here in this entire time. Ooh, extrema? There's an extrema at 0, 3. 0, 3, isn't that right here? So there's going to be a minimum. That means a bottom, correct? So there's going to be some kind of bottom right here. I can draw a bottom right now. You just told me it's going to be positive all the way over here, correct? Up here is positive. So I don't think it matters what I draw over here. This kind of fits the description, correct? It's positive for x is less than 0. It's up here. It's got a minimum at 0, 3. That's the y-intercept. Okay. It's decreasing, going down for all x is less than 0. So far, this is working. It says nothing else. It just says end behavior now. So let's kind of wrap it up. As x goes to infinity. So as x goes to infinity, to the right, correct? This function goes up to infinity, which it kind of has to, right? This is a minimum. It probably is going to go up and up. So it doesn't matter what you draw. How about that? This is like a best guess kind of thing. And then it also says that x goes to negative infinity, which means to the left. This function goes to positive infinity also, so it still goes up like this. So maybe something like this. Is that kind of, do you buy this? Let's the y-intercept is 0, 3. Yeah. Is it non-linear? That ain't no line, right? Was it continuous? Could you have drawn this in just one big stroke? Yes, I could have. Is it positive for all values of x? All values of x, it's always above the axis? Yes, it is. Decreasing for all x less than 0? Yeah. Extrema, minimum at 0, 3? Yeah. And then end behaviors match as well. So that's a fine sketch right there. Does yours have to look exactly like mine? No, no. Another answer could have been if you'd drawn this. I could have put some humps here or whatever. Does that still meet the criteria? Yeah, it still has a minimum there. It's still positive for all x. It still goes to infinity. So you can have a lot of different graphs, but one of them that you choose on your work will be the most appropriate. Questions over that? Okay. Let's go ahead and do a couple more, then we'll call it a day. Yes. All right. Last couple for the day. Call example, something like that. Whatever you want. As long as you're just reading everything and double checking it, then your graph can't. All right. Let's dive in with the quote unquote number 1 on the board. Example number 3, but number 1 on the board. All right. Just get, here we go. We're just going to go through and make sure we hit every condition. X-intercept at 2, 0. So that's where it crosses the x-axis at 2 over and 0 up and down. So we got that point right there. Check. We got a y-intercept. All right. So it crosses the down here at 0, negative 6. 1, 2, 3, 5, 6. Something like that. This is 2. All right, we got those checked off. Oh, now this is going to be easy. Linearity, it says linear, so it's a line, right? Do I even need to read the rest? If I already got 2 points and it's a line, it's just got to connect those 2 points, right? So I'm going to do that. I'm going to assume this is okay, and then I'm going to go ahead and go back and double check that it actually does fit every other condition. I think that's probably fair. Continuous, could I have drawn that without picking up my pencil? Yes, I could have. Positive for all x's more than 2. So when x is more than 2, is this above the axis? Yes, it is. Increasing for all values of x as I come in for negative infinity and I walk from left to right, is always going up. Yes, it is. End behavior as x goes to infinity, to the right. The function goes to infinity. Check, right? And lastly, as x goes to negative infinity, the function goes down to negative infinity. It all makes sense, right? It's nice how you graph a few things, and then if you know enough about things, you can graph it, and then everything else makes sense. Like, oh, yeah, it is continuous, and it does have to be this. So good example on that one. And the last one won't be much worse either. Can you see why number 2 isn't going to be that bad either? I see a key word in it again. It's linear. It's just going to be another line thing, just another line deal, just like before. Once we figure out a couple spots on the line, if we can, then we'll be fine. Okay, they gave you an x-intercept, right? 0, 0. That's the origin. So there's where it crosses the x-axis. Awesome. They gave you a y-intercept. Also 0, 0, which makes sense, right? Because that's also where it crosses the y-axis. Check. All right. It's linear, so I'm going to draw a line, correct? It's continuous. Well, yeah, I'm going to draw a line continuously. All right, positive for values x less than 0. So for x is less than 0, this thing's going to be positive. So I'm thinking it's probably going to come somewhere up here, come straight down through this line and to this point and go down here. That makes sense, right? But where? Is it going to be slanted like this? Is it going to be slanted like that? I don't know, do I? So let's read more. Hopefully there's something in here. It's negative for values of x more than 0. Well, that makes sense. If x is more than 0, then this thing's going to be negative, and right? Decreasing for all values of x. Yeah, it's always going to go down, right? And end behavior, as x goes to infinity, this thing's going to go down to negative infinity. Everything says the same thing. Do I have any information about the slope, though, or anything? I've read it all. I can't figure it out, can I? So there's multiple answers. If one of you wants to draw this, is that acceptable? Yeah, that's fine. If somebody else wants to draw this, is that acceptable? Too. So there's infinitely many answers for some of the problems. Not any one of you might have the exact same answer on your graph, but as long as you're hitting the conditions, you're good. And that kind of concludes the lesson for today. Make sense? I think so too. I don't think you guys need any more browbeating. Yes, so that's it. Homework 1.4 is over this. Homework 1.3 due today. And you got a good points left. So if you got any questions over 1.3, let me know. If you need to do 1.4, you got questions over that, let me know.